All right, we're going to continue with our finance part one. So we've been looking at simple interest, but now let's think about what goes on at an actual bank. So what happens when you have a bank account, any interest that you earn is automatically added to your balance. So what happens when you are gaining interest is that you're going to earn interest on top of the interest that was just put in, and then every month or quarter or however often that it's compounding, you earn interest on top of interest. So your interest will continue to grow, which we call compounding. And it starts out slow at first, but then as time goes on, it can make a really big difference. So often banks will advertise a percentage rate, and normally it's an annual rate, which means yearly. But when we end up kind of compounding and adding interest in a time that's less than a year, we take that interest rate and we got to divide it. And so the way that works is if we're looking at annually, that would mean once a year. Semi-annually would be twice a year. Quarterly, like 4 quarters and $1, would be 4 times a year. Monthly would be 12. I'm going to skip bi-weekly for just a second. And just in case you didn't know, there are 52 weeks in a year. And so bi-weekly would mean every other week. So that would be 26. And then we have daily, which will go with 365. And so our interest rate, if we're looking at like 6%, we'd have to take 6% written as a decimal and divide by whatever our compounding amount is. For a year, it would just be over 1, so that's why we're still just looking at 0.06 or 6%. We could take 0.06 divided by 2, so that would mean that we'd earn 3% by looking at it at that time. Quarterly, 0.06 over 4, which is 0.015, 0.06 over 12, which would be 0.005 or 0.5%, and so on. I'm just going to write the other ones because they're going to get a little bit smaller. But you can see we're just taking the interest rate and dividing it up because, again, that was the annual interest rate. So let's suppose that you deposit $1,000 into a bank account offering that 6% interest, but we're going to look at it compounding monthly. And so we want to identify all these little parts about what's going on and try and figure out how much money we'll have after the first month using that amount as the new principal. Find out what happens the second month. So let's just look at the first month. So we know that the amount of money that we have is equal to our principal amount plus our interest. Remember that our interest can be found by looking at the principal times the rate times the time. And so what we're looking at here is 1,000 plus, we're going to take a percentage of that 1,000. Now, it's not 0.06 because we need to take into account the compounding. So we're going to actually multiply this by 1/12, and you can see that this amount is that percent that we were talking about up there. And so this is going to be equal to 1,000 plus, when we multiply out that amount, it's going to be equal to 5. So the amount of money that we have is going to be $1,005. This is after 1 month. And so you can kind of see the 12 here being the number of compounds. You can see the rate, and again, you can see the principal. So now it says after the second month. So what's going on here? After 1 month, we have this much money. So now when we try and calculate the amount, we're going to be looking at starting with that $1,005. And so we're going to take a percentage of that. So 0.06 times that 1/12. So this is going to be equal to 1,005 plus, this is going to be a little bit more than that $5 because we're starting with a little bit higher principal. And it doesn't look like that much at first. Oops. But we'll have $1,010. But you can see it grew a little bit because he had that additional money in there already. So So when we flip over to the next page, let's think about this in terms of that recursive formula, which we've seen before, because if you look at it, we're using like the new balance after the previous month. So we could say that we know that we have our P naught, and so then P1 is equal to that first initial amount plus the interest. Like we already know that part. I'm just kind of copying this going on here. And so we know that it's going to be equal to that 1,000 plus 1,000 times 0.06 over 12. So then for our P2, this is going to be equal to our P1, the previous guy, plus that P1 times 0.06 over 12. And P3 will be equal to the P2. So that's what I mean by recursive. It's using the thing that came before it, which is just the previous month's balance. And we keep going up to P4, it said. And so just something else to kind of keep in mind here is that another way to look at this amount is that they both have that 1,000. And so if we use the distributive property, but kind of backwards, taking that out, we could put 1 plus that 0.06 over 12, which is really going to be 1,000 times, remember this was 0.005, so 1.005. And so when we look at this amount, again, you can see that P1 in both places, so I could write P1 times 1 plus 0.06 over 12, but that's really P1 times 1 plus 0.06, 0.05. And I could rewrite all of them this way, following that same pattern. And so you can see it's really the previous one times that 1 plus 0.005, or you can even write it, I guess, 1.005. No, I'm writing it that way. So we could say like P3 and then 1.005. That's really what's happening. So we're going to like derive the formula for compound interest by noticing that these are really the same thing, just the previous one with that same 1.005. And so we're writing P1, we could say that that is equal to that P naught, we said, times 1 plus 0.06 over 12, but using those numbers and letters here, we're looking at the amount after 1 month would be equal to that, but 0.06 is our rate and 12 is our K. So we're looking at it as P naught times 1 plus R over K. And so when we look at P2, we know that P naught is already given to us, but we said, sorry, P2 is P1 times that 1.005, right? That 1 plus R over K. So we have the P naught being replaced, or not really replaced, but this whole thing going in the place of that P1. So it's P naught with a 1 plus that 0.005 or R over K, but then we have another one. Right, because this is 0.005, and so you can see that replacement. And so really we're going to get 2 of those when we're at the second month. And so like P3, remember P3, oops, it moved. P3 is really the previous one times 1 plus 0.005. So if P2 was this, and then I need another one of those 1 plus 0.005s, that's really another 1 plus R over K. So we're going to say P naught times 1 plus R over K squared times another 1 plus R over K. But really that's just P naught times 1 plus R over k cubed, because now we're going to have 3 of those. And so if we kind of continue that on, P4 would be P naught, and then we would get 4 of those. And so using that same pattern, like 5 years, well, that's 60 months that we're really talking about, right? Because 5 times 12 equals 60. So P60 is going to be P naught times 1 plus R over K to the 60. But thinking about using another letter they have up here, which was N, number of years invested, what we could say is that that 60 came from the 12, that was the number of compounds, which is K, times the number of years, which we're going to say N. So that's N and K. So I could rewrite that as KN. And we could say that this is our actual amount. So our amount is equal to P naught times 1 plus R over K to the KN, where that is in years. And that's the number of compounds in a year. And again, this is our interest rate annually that we end up splitting up based on those compounds. And we have P naught being our principal starting amount, and this is our amount after time has passed. Some people call it like that future value. And so if we flip over to the next page, you can see it written again. Look, we came up with that. So you can see all of the notation that we used here. Again, P naught, that starting balance, also known as principal. R is the annual interest rate. K, number of compounding. And A, the balance after those years have passed. So for exercises 7 and 8, we're going to be able to use this. So we have Jasmine receives $1,800 in graduation gifts. And she's going to, which she earned when she graduated at 22 years old. She's going to deposit that into a savings account that has a 5.5% interest rate compounded daily. So that's $365. And again, that's our principal, that's our P naught. Our interest rate written as a decimal, 0.055. And we want to know how much is going to be in there by the time she's 65. So if she's 22 now, 65 minus 22 is in 43 years. So we know that the amount she's going to have in 43 years will be equal to that principal amount, which is 1,800 times 1 plus 0.055 over 365. And we're going to take all of that to the 43 years times 365, because that's how many times it will compound. 43 years every day, that's a lot of days. If we actually multiply that out, you're going to get that we're going to take it 15,695. So in your calculator, and I'll do a separate video to show you how I use Desmos, but I would divide this first in my calculator, then add that in. Then take it to the exponent, which on your calculator it might look like a little caret button, it might look like a y to the x button, and then after that multiply by that 1,800. And if you did do it correctly, I mean, you can use parentheses, there's a lot of different ways. The Desmos calculator is really my favorite because you can see the exact expression that I wrote here in Desmos. It just writes it really nicely. When you do it, you have $19,000. So she started with only 1,800, and in 43 years, she'll have almost 20 grand. Pretty good, not putting additional money in. We'll learn more about that later, where if you make monthly deposits, how that can impact things. So now suppose that you have a new baby, and you know that you're going to need $40,000 for your kid's education in 18 years. So $40,000 is the amount that you know that you're going to want to have. 18 years is our time. And it earns 7%, that's 0.07 for our rate. Compounded quarterly, that's 4 times a year. That's going to be our K. So it wants to know how much we need to deposit. So the question is actually finding that P naught. So we know that 40,000 is equal to whatever the P naught is, times 1 plus 0.07, our rate, divided by 4, because it's quarterly. Now we're going to do this for 18 years, so we're going to take 18 times 4, which is a total of 72 compounds. So our goal is to solve for P naught. P naught is right now multiplied by this big ugly chunk. So if I want to put it on the other side of the equation, I'm going to divide by it. and divide by it. And so what I really need to find on my calculator is what 40,000 divided by that chunk of stuff is. And again, on my calculator, I would actually use something called the answer button, but on Desmos, I can enter in just like that. And when you calculate it, you should end up getting $11,470.49. And then what's cool, because that's kind of weird way, we're kind of missing something that's inside that big equation, you can always check it. So to check it, I would take that as my principal and make sure that I end up with $40,000 once I plug into that compounding quarterly. And if you do, you'll get, because we rounded a little bit, we're going to get just a little more than $40,000.